Hi everyone. In the last video, we introduced Markov decision processes and showed how to compute state values using the Bellman equation. We also saw how to get a policy, this, from the value function by picking actions that lead to the highest valued state. But we haven't yet answered some important questions. For example, what makes a policy optimal? And how can we compare different policies and find the best one? Imagine we can have like different, maybe hundreds of policies, different depending on the environment. This is just a single policy, but maybe another policy can tell you to go left from state 11. So in the previous video, we got this policy from the value function, and formally, the way it is so essentially from a value function to a policy, this is more like the equation, right? The policy for a state, or the action of a state, is the argmax for all the states. This argmax is like we choose the action that maximizes the expected reward, expectation, the next state, probability state action, immediate reward plus gamma times the value of the next state. All right, let me quickly explain this. So essentially what this tells us is look at all the possible actions available to us from, let's say, a current state S, okay, and choose the action that offers the highest expected total reward, which is the immediate reward, which is computed as the immediate reward plus the discounted future value, this, okay. So in the previous video, I simplified this calculation by directly using the state values. I ignored the immediate rewards when picking when choosing the policy. But the complete equation explicitly includes the immediate rewards and the discounted future values. So formally, to get a policy from a value function, you can use this. Now, we can also think of the problem the other way around. Imagine someone gives us a policy and tells us to get a value function. I mean, given that policy, from that policy to a value function, we can actually get a better value function. And okay, if we, I mean, of course, someone gives us a policy, we can get the value function by maybe using a modified version of the Bellman equation, something like this. So a value function that relies on a policy, let's say immediate reward, and then the action will rely on the, instead of just action, the policy is going to determine, the given policy is going to determine the action of the state that we are computing the value of, then gamma value of the next state. S prime is next state. Okay, so this is going to be the policy is going to determine this, and this is the discounted future value. All right, so the value of a state under policy pi, what this tells you is the immediate reward plus the discounted value of the next state, and we can call this a policy induced value function. Let me quickly give you an example. Let's say someone gives us this policy. Let's compute the value of state 6. Well, the reward is going to be reward of state 6, while in state 6 the action is go left. The policy tells you to go left, so left, plus gamma, well, gamma is 0.9 times the value of the next state. The next state is state 5. I mean, from 6 you go to, the policy tells you to go to state 5, so I'm going to put the value of, I'm going to put 5 here. Okay. And by the way, I'll use the same reward and the discount. Yeah, I'm using the same reward and the discount factor from the previous video. So we got this from the previous video. I remember in the previous video, for all the actions, the reward is -1, 0.9 times. Well, the value of the next state is -0.66. And then let's see, I mean, I think it should be around, let's say, -0.69. Yeah, I think so. All right, so far so good. Now we can compute the value of a policy, right? Using this, we can also compare different policies. So essentially, let's see, we have two policy, pi and then pi prime, and we can say pi is better than pi prime if, say, the value greater than pi prime. Let me quickly, for all the states. So essentially we say that policy pi is better than policy pi prime if it gives us higher or equal value for every state. Let me move this. Okay, so this tells us that some policies are better than others, and naturally we want to find the best one. We want to find the best one, the optimal one. Now, since the value function is bounded, I mean the values cannot go to infinity due to discounting, we can define the optimal policy as the one that maximizes the value function. So essentially this is our optimization problem. Max, for all the policies that we can have, value say. So essentially this is our optimization problem. So we are looking for the policy pi among all the policies that gives us the highest value for every state. And the solution, we can refer to the solution of the problem as the optimal policy pi star, and the associated value function as v pi star, or we can call it v star. By the way, maybe you can get this v star from pi star using the, let's see, policy induced value function. And the goal of an MDP is to find the optimal policy. All right, so in the next video I will introduce the Bellman optimality equation and the state action value function. Thank you for watching. If you have any question, please let me know in the comments. Bye bye.